Hi, hello everyone. Welcome back to ANR Academy. Today we are going to discuss how to find the area of asteroid. You know that the equation of asteroid x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. I am going to write the equation of curve x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. With the help of definite integrals, we can find the area of this curve. Let us draw the graph of curve first and then we go for integration. Suppose this is x-axis and this is y-axis. Their point of intersection here origin. To draw the graph of this curve, first I am going to put x value 0. When x is 0, what happens? Observe, y power 2 by 3 that become a power 2 by 3 implies neglecting power 1 by 3 on both the sides, we get y square equal to a square and hence the value of y equal to plus or minus a. Next, if you write the value of y equal to 0, due to symmetry in x comma y, I can directly write the value of x as plus or minus a. So that 0 comma a, 0 comma minus a comma 0 minus a comma 0 are the points you have to mention here. This is a comma 0 and this one minus a comma 0. This is a comma 0 here, minus a comma 0. Next 0 comma a. Next 0 comma minus a. So the curve passing through these 4 points. And if you write the values of x less than a, then it gives the positive result. And you will get the graph in this way. Now you need to find the area covered by this curve. That is the requirement area. I am going to shade with different colors. This is the area in the first quadrant and this is the area in fourth quadrant. This shaded portion in the second quadrant and this is the shaded portion in the third quadrant. So this area we need to find, so that it is enough to find area in the first quadrant, and then if you multiply this with 4, then you will get the entire area. Why? Because the graph is symmetric about x-axis as well as y-axis. Whatever the area you have in the first quadrant, the same area you have in second, third, fourth, so that required area that can be written as 4 times shaded portion in the first quadrant, quadrant 1 area. Okay. So now let us move to the proof how to find the area with the help of definite integrals. Here I am going to write required area is 4 times area in quadrant 1. Observe this figure. The curve in the first quadrant defined from 0 to a, and the graph is entirely above x-axis. So I can write by the definition of definite integrals, it starts from 0 up to a and here you have to write the function f of x dx. Integral a to b f of x dx indicates the area under the function f of x in between the boundaries x equal to a, x equal to b. The same here, 0 to a f of x dx indicates area under the function f of x from 0 to a. This portion, first quadrant shaded portion, you will get. Multiplying with 4, we get entire area. F of x is nothing but clearly y. So I can write here 0 to a y multiplied by dx. We know that given curve x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3, and the parametric form of the curve is written as parametric point I am going to write on this curve, that is x equal to, if you write a cos cube theta and y equal to a sin cube theta, the point x comma y a cos cube theta comma a sin cube theta satisfies this curve. Let us cross check. When you write the value of x a cos cube theta in this, you will get a power 2 by 3 cos cube theta whole power 2 by 3. Next, in place of y, if you write a sin cube theta, that become a power 2 by 3 sin square theta. From both, if you take out a power 2 by 3, internally we get cos square theta plus sin square theta, that become 1, and hence we get a power 2 by 3. So this is parametric point. With the help of this parametric point, here I am going to write the value of y. You know that y coordinate a sin cube theta. Next, you need to write dx. You have here the value of x a cos cube theta. So from this, the value of dx written as a cos cube theta derivative, a constant, so that write as it is. Next, cos cube theta derivative, that is 3 cos square theta multiplied by minus sin theta d theta it is. It looks like x cube. X cube derivative 3x square, right? So that cos cube theta derivative 3 cos square theta and internal part cos theta derivative minus sin theta. So that dx can be replaced with minus 3a cos square theta sin theta d theta. Now I am going to write minus 12a square outside. Next, sin cube theta into sin theta, that become sin power 4 theta and its multiple cos square theta d theta you have. Right, next. Let us discuss about the limits. Here you have lower limit 0. Here the substitution y equal to a sin cube theta, right? X equal to a cos cube theta also. Here the limits with respect to x, you have x equal to 0 lower limit, x equal to a upper limit. When you write x value 0 in this, then the value of theta become, this is pi by 2 clearly, cos 90 0, right? Next, when you write upper limit a, then theta become 0 degrees. Why? Because cos 0 value 1 and hence the value of x become a. So limits 0 to a changes to pi by 2 to 0. Lower limit pi by 2, upper limit 0. Here lower limit pi by 2 and you have to write upper limit 0. On simplification it become, here I am going to change the limits from 0 to pi by 2 if you write, then outside the negative sign you have to neglect. So 12a square, and then you will get sine power 4 theta cos square theta d theta. Next, constant 12a square outside, integration from 0 to pi by 2. Next you have sine power 4 cos square, sine power 4 theta cos square theta d theta you have, right? Now you have to apply reduction formula to find this integral. You know that when you have limits from 0 to pi by 2 and the integral function of the form sin x whole power m cos x whole power n, then you have the result. That result, reduction formula result, I am going to use now. You know that integration of 0 to pi by 2 sin x whole power m cos x whole power n dx, that is, and here in this case m comma n both even numbers. When m comma n both even numbers, then the formula for this, in the numerator m minus 1, m minus 3 and so on up to 1 multiplied by n minus 1, n minus 3 and so on up to 1 whole divided by, in the denominator part you have in the formula m plus n, m plus n minus 2 and so on up to 1. Due to mn even numbers, you have to multiply with pi by 2. Actually, this is the reduction formula. Using this reduction formula, you can write the integral value of this function. So now I am going to substitute the values of m n in this. You will get 12a square outside. Using this reduction formula, in the numerator we get 4 minus 1, that is 3. Next 4 minus 3, nothing but 1. And then you have n starts with n minus 1 up to 1. N minus 1 nothing but 2 minus 1, that is 1. Next, in the denominator part, now only numerator 3 into 1 and 1 by the formula. Next, in the denominator part, m plus n. M plus n is nothing but 4 plus 2, that is 6. And with the difference 2 you have to write. So 4, 2. Either 2 or 1 here in the formula. And due to both even numbers, you have to write pi by 2. Now I am going to simplify this. Here you have 12 and 6 into 2 also 12. These two gets cancelled. And now you will get finally 3 pi by 8 multiplied by a square units. This is required area. So on solving the integral value, you got finally 3 pi by 8 into a square. It's really very lengthy proof. So in the entrance examinations, if you have a question based on asteroid type, that is the functional equation of this type, x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3, then directly you have to write the area 3 pi by 8 into a square units. So this is the answer. This is the short method to find the area of asteroid. Suppose the question given in the examination, suppose like this. If the question asked in the examination, if find the area bounded by x power 2 by 3 plus y power 2 by 3 equal to suppose 7 power 2 by 3. This is the question. Then here the value of a is 7 And you know the short method, required area 3 pi by 8 into a square. So that 3 pi by 8 multiplied by a square value, that is 7 square. So that finally 3 pi by 8 into 49. 49 multiplied by 3, that is 147 divided by 8 into pi. Area must be denoted with square units. So this is required area of asteroid. So using this short technique 3 pi by 8 into a square, directly you can write the result. In the entrance examination, if you substitute the value of x equal to a cos cube theta and y equal to a sin cube theta, and after that by applying reduction formula, you will get the result, but that is very lengthy method. So to avoid lengthy time, you have to remember this formula 3 pi by 8 into a square. It helps you in the entrance examinations. Thank you so much.